Hello, today I will talk about how can we get the derivative of an inverse function. For that, let's start with an example. Suppose that we need to have the derivative of the arcotangent of x. We don't know what is that right now, but we know this property because it is the inverse function. The composition of the tangent and the inverse of the tangent will be x, okay, for sure. So let's get the derivative of this using the chain rule, right? For this we will need to have also the trigonometric identity for the second, and this is coming from the Pythagorean trigonometric identities also, by the way. So we apply the derivative in both sides. Here we will get 1, and here we have two functions in the composition, so we need to have the chain rule. In this case, the derivative of the tangent basically will be the secant squared of the angle. In this case, the angle is the arcotangent of x, multiplied by the one that we don't know, equal to 1, right? So we will have something like this at the end, right? We know that the secant square of the arcotangent is equal, by the trigonometric function here, trigonometric identity, excuse me, is this, but the tangent square of the arcotangent, this is an inverse function, so using this property we can substitute it by x, so this is x squared. So we will have this multiplication equal to 1. So what next is just to simplify. We will have that the derivative of the arcotangent is equal to 1 over 1 plus x squared. So now we can go and generalize the concept using the chain rule. Whenever we have this kind of behavior one-to-one and continuous, we can perform this derivative. We know that in one side it will be 1, in the other side we can apply the chain rule. So the chain rule will have this form, and then we just move, if this is multiplication here, we will divide it everywhere, and we will have this general function, right? So now what? Let's show some examples with the inverse of the sine and the cosine. This is one of the examples that I have for the sine. The same thing, we don't know what is this, right? But we know from this formula that if wherever we have the inverse of a function that is one-to-one and continuous and all the properties that we need, we can apply this formula. So the derivative of the original function, we may know that composition to the inverse of the function. In this case, the derivative of sine is cosine, and we have the composition of the arcosine x, right? But we can recall that the cosine of theta is the square root of 1 minus sine square of theta. This is also coming from the Pythagorean identity. Therefore, I can do the substitution of this, right? So in this case, this cosine will become this square root, and this part, as we know here, is also x, so we can substitute that back to x, and we will have the derivative of the arcosine of x, right? Same thing with the cosine. We just apply directly the formula this formula that we have here, minus sine is the derivative of cosine, the original function, doing composition of the function, the arccos of x, right? And the sine, again, we have Pythagorean trigonometric identity, which is equal to the square root of 1 minus cosine square of arccos of x. And this part, basically, this is the inverse of the same function, so we can replace by x, and that's this.